My name is Wayne Costa Martins.
My name is Isidro Pantoja Gomez.
My name is Jesus Ramirez, and we're the Three Musketeers. We worked on Project 3 Sustainable Urban Planning.
So this is how it works. We're going to run it. So this is our GUI. It has the city maps, the solar panels, the wind turbines. It has a save and load feature and a bill of materials button. So what you want to do is you want to select a city, such as Los Angeles. And we have a 30 by 30 grid loaded up. And then when you do the solar panel, so you choose a solar panel, and it's either, this is out of the array of solar panels, so you just choose one, and it gives you a crosshair, and this allows you to pick the various grid tiles you want to place the solar panel or wind turbines in. So we have a max of 10 tiles that you have to do, but you can switch out solar panels or wind turbines, and you get different colors. Okay, so this is our code for the grid lines. We call in the string that's so this is the string from the list box, and this is getting in the value from the list box. So we do an if statement for Los Angeles, which basically gives us the city, and we use the imread command to load in the image, and then we set the axis. Axis 1 is what our image is called, where the axis is on the image, and we use two for loops to draw the loop in, and each box is approximately 46.5 feet across, and we do this for each city. So as you can see, each city has the same code that's tied to it, and each city has the vertical and horizontal lines, so we don't have to do a separate function for that. So we move on to how we select the different colors. So we have multiple if statements and G input commands that allow us to select a different color for each city. So we have different colors like red, blue, or we also manipulated the face color command to have slight different intensities that allow us to have different colors. And this is the same thing with the wind turbine. We have different if statements for each wind turbine.
So I'm Jesus, and I'm going to be explaining the save and load functions as well as the bill of material buttons. So once you've finished on the GUI and you want to save it to work on it later, you have this button. So once you click on it, it'll ask you to name the figure. So today we're going to name it Los Angeles. Then once you press OK, it's going to ask you where to save it in a folder, so we're going to save it here under the Engineering 6 Project 2. You open it, and it should be saved. So once the user wants to go back and add some more turbines to it, you press the load button on the GUI. You click on the one you just saved, so the one we used was Los Angeles Fig. You open it, and it should appear once again. So now that we open up a loaded file, we can click on the bill of materials, and that allows the user to see the quantity of the different solar panels and wind turbines that they used, and the total price that it would cost for them to actually place it. So here, once we click on the bill of materials, this bill of materials text should pop up on the side, and this text document should pop up. Here we have it titled Bill of Materials. Here we have the different solar brands, the models, and the types. And down here we separated with wind turbine brand, wind turbine model, and the type, and then quantity price. And here we see all the different types of solar panels and wind turbines that they used, and it will display the total cost. So now I'm going to show you the code. Here we have a function called push button 1, and this is the save function that allows the user to save their previous or save the work they were working on. So we named the input DLG as file name, and then we put a string name for figures, and that allows the user to name the file that they're trying to save. Then we use the UI get dir, and it asks the users to select a folder to save in. And so if they don't input a name, it's gonna ask the user to choose a name. So it'll just keep asking the user if they don't input anything. But once they do, they have two options. They can save it as a FIG file, or they can save it as a PNG. So we have two different formats that they could save it in. So that leads on to push button 2, which is the load function. Here we have the same command, the UI get file, and we have it as a FIG. So open file name, that allows the user to open up their previous saved work, and then with this GUI data, that allows to pop up the file. So lastly, push button 3 is the bill of materials button on the GUI. So first things first, what we did is that we created an array for all the different brands, the models, and the type arrays for both the panels and the turbines. And so down here, we concatenated the prices of the turbines and the panels into a total price array, and also we did the same thing into a total num array, so which is the quantity of the turbines and the panels. And then lastly, we took the total price array and we summed it all up into a total price. So down here we have BOM and fopen, which opens up a BOM text, which is over here in the folder. So that creates a file to save the text. And over here we just used fprintf to display all this, which ends up looking like this. We did the final total cost, so that would be right here. So this line right here just shows the total price that would be for all of the different wind turbines and solar panels that the user used. So yeah, that's the
hi, so I'm going to talk a little bit about how we were able to find the price for the solar and wind panels and the power used by them. So first we had to go to the data that was given to us right here, city, solar, and wind power. So if you go to that, our cities were Los Angeles, Houston, and Chicago. So then if we go to the solar, so LA was city 5, so this is the array for it. So, and this is the wind for it, city 5, since it's row 5, and all these columns are the 12 months. So we use that here to find this number, which is the price of the solar panels that are going to be in the price and the watts of the solar panels that are going to be in each one. So first we found the square footage of the solar panel individually. Then we divided the square footage of our whole box, which is 1,011 square feet per box. So that gave us the actual number of solar panels that fit inside each box. Then we multiplied times the price. Then, since our data is in feet squared and the data that was given to us was in meters squared, we had to multiply times this converter, and that gave us the watts of energy used. And then we also had the power percentage used right here, so like how much power there was possible for that solar panel and how much was actually used because of the city's ability to get light. So we did it for each solar panel of each city. And then for the wind energy, it was pretty much the same, except now we had to convert, since we were giving our data over here for the wind, it was in miles per hour. So 2 miles per hour monthly, 1 mile per hour monthly. We had to convert that to wind energy, which was 600 miles per hour per kW, and then per MW, I guess, per power. And then since almost all of them got enough wind energy to where it maxed out the power of the wind turbine, we had to do it just 100% used, and we had to subtract the extra since it can't use more wind power than what it's possible to use.